All right.
You stopped it? What
Yeah.
the hell?
How many people were right?
I know that
Well, everybody got the first one right. I didn't look at the second one.
it was 5.
Everybody got the first 12.
Almost everybody. It's not enough.
I didn't even know we had some
I
credit.
just did the square
That's
root.
5.
He's too late.
It's too late. I just had so many questions
Alright, we're
about
gonna
my
talk about it.
test.
All right, so we're gonna see how to put these in Socrative. As long as you answered something, you get points for this. I'm not
You didn't let me.
worried about you knowing how to do them yet. All right, so in Desmos here,
What?
we've done square roots before, right?
Yeah.
This button right here is square root. Well, it's a little different. And this whole chapter is about radicals that are not square roots. So to find it, it's kind of annoying. We have to
this
go over
one.
here to functions, click on that functions button, and then it is in miscellaneous,
Say
and
what?
it's right here.
Misc?
Yep, it's below the percent. And it'll look like this.
No.
And then the first one was the 4th root of 625. We're going to type in 4 on the outside there. We're going to go 625, and that's what it shows you on the inside. And then the next one was... what was our
I'm
last
just gonna
one?
leave it there. So
1728.
that'll eventually.
Yeah, so what is the third root of
Shouldn't leave this
1728?
Yeah.
Was 12. Second one was 12. So that's how you plug those into Desmos, just so you know. As long as you had something in, you get points. I didn't expect you to know them all.
See, it wasn't 13.
So this first one was 5. This one was
I can't read lips.
Alright. So this whole chapter that we're going to be looking at is all about these things here. These are called radicals. So this whole thing is a radical. So I will usually call it radical from now on and not just square roots because we're not using square roots very much anymore. And it's made up of 2 pieces. So this little number here on the outside is called the index.
Windex.
This little number out here is called the index.
Okay.
And then inside here, and I almost never use this word because it's kind of hard for me to say, it is the
Oh, I thought it was
radicand.
gonna say equilibrium.
I really got to emphasize it. Radicand. Make sure you guys are taking notes. These notes are worth points. Some of you guys still haven't done your notebook check for the last chapter.
What was the word you couldn't say? It was like equilibrium.
Oh! Alright, and so the way we read this is, we would say 5 is the 4th root of 625.
That's weird.
You're weird.
So a root...
Got him.
Smart about that.
Without
That's
that.
the only thing.
No, you guys can use this at other places. I mean, I don't have examples off the top of my head. It doesn't mean you won't use it. Actually, yeah, you could use this figure to find some
And
equations.
Chinese characters.
Chinese character.
Alright, so, hey, make sure you guys are getting these. Take notes.
I am.
Okay. So a root is a number that can be multiplied by itself a certain number of times to equal what we want. So,
25
this
is the 4th root.
5 is the 4th root. That means if I go
5
5 times
times 5.
5 times 5 times 5, that will equal 625.
Nuh-uh.
And a lot of times these are easier to not think of it like a radical. Don't think of it with this little radical symbol here. Sometimes it's easier to look at them backwards and say what number times itself 4 times equals 625,
5.
which in this case is 5. So these are really the same thing. And we're going to talk about this more later, not today, but later. These are really the same problem right here. They just look a little different.
Wait, what?
So this right here
Just opposite.
and this is really the same problem. Yeah. So it's kind of like if I had a 1 plus 2, that's really the same thing as a 2 plus 1, right? It's just written differently. Same kind of idea. It's just written differently.
So it was -2.
So we're going to be working with some radicals here by looking at kind of the opposite version. So if I were to go through and if I had a problem like x squared equal 4, how would I solve this?
Who has like a...
If I had a problem like x squared
you
equals
square
4,
root it.
how would I
Square
solve
root
it?
You don't.
Like square root it, right? Do this.
2.
What if I had something like x to the 4th equals 16? How would I simplify that?
Put it in x squared.
2 times 2 is 4.
Put it x
Times 2 is
squared
16. It's 2.
to the second.
Actually, that would work. That would work, Daisy. But there's an easier way.
Oh,
All right. So the reason we square root a squared is because a square root is really a radical with an index of 2. This is a square root.
What's a radical?
Radical is this symbol right here. Okay? This is a square root. It's really an index of 2. We just don't write it because math people are lazy. It's kind of like saying, if I had an x right here, what number's in front of it? And what exponent does it have?
18.
1.
But do we really write those down?
Yeah.
No. Same thing with square roots.
Unless you're
There's an
weird.
index of 2 there, we just don't write it down.
Unless you're
So, if I'm going to get rid of this exponent of 4, to do that, I'm going to work backwards, and I'm going to add in a radical, and my index is going to be the same as my exponent. And again, we're going to talk about this more later. So if I was going to solve this, that's what I would do. And so what we're going to look at right now is if I have something to an exponent, we're going to look at the type of answers we get. So, if I have a number, an exponent of n, and it equals b, there's a few things that are going on. If n is odd, n is my exponent. We're going to have one real answer. And that is going to be at whatever the nth root of b is. So for example, if I had x to the third equals 27, to solve that, to get rid of my exponent and solve it for x, I would just take 27 and I would take the third root of that. I would take the third root of 27. Whatever I get is my answer.
Ouch.
Should I write that down?
Now, this is where it gets a little weird.
Oh yeah.
So, if n, my exponent, is even, and b is this answer over here, if that is positive, then we're actually going to have 2 answers. So, we're going to have 2 answers. One is going to be at the nth root of b, and the other one is going to be the negative nth root of b. And this is where it's a little weird. Alright, so let's say I have x squared equals 4. I'll just kind of continue that example, right?
This is so stupid.
Okay, x squared equals 4, right? If I'm going to solve this to find out what x is, I would get rid of my squared by doing a radical with index of 2, which we usually call a square root, right? So I square root this and I get x equals, what's the square root of 4?
2.
Okay, but there's one other thing. If I plug in 2 in for x, 2 squared is 4, right? What's negative 2 squared?
4.
What's negative 2 squared?
Original 4.
4.
Positive 4, right?
Yeah.
The x squared equals 4 has 2 answers. Positive 2 and negative 2.
So you're just
So we have to write both. So, whenever your exponent is even, you actually have 2 answers. If your exponent is even, you have 2 answers. A positive and a negative version. Because
I mean, odd.
anytime you have an even exponent, inside there, negatives disappear.
Why is there 2 rules?
So, if I had, say, an x to the 4th equals 16, I would have a positive and a negative version because my exponent is even.
Wow.
If your exponent is odd, you just calculate it, you plug in a number, and whatever you get is what you get. There's only one answer there. But if it's even, I get 2 answers. With one exception. So, if your exponent is even, and what it equals is negative, there are no answers. There are no real roots, just imaginary roots. So, for example, if I had x squared equal negative 4, what kind of answer am I going to get?
Imaginary.
Yeah, we're going to get an imaginary. So I get rid of my squared by square rooting, my radical with index of 2. And I can't square root a negative, right? I have to do the imaginary thing. I would get I square root 4, keep going, back out.
What are the real cube roots?
So we have 3 situations.
0.
If your exponent is odd, you have 1 answer and you just plug it in and whatever you get is what you get. If your exponent is even, you're going to have 2 answers, a positive and a negative, as long as it doesn't equal a negative.
Oh, yeah, this is
If
stupid.
your exponent is even and it equals a negative, you've got an imaginary type of answer. So we're going to go through and look at some of these.
ouch.
Ah. Why are we doing this?
We're learning radicals.
Why?
One.
Yeah, then you go back.
Oh.
Just need
We
one.
didn't need the,
Oh,
we
I can
didn't
have-
need the problems off the side, did we?
No, they were just examples.
Okay.
For your benefit.
I don't plan on using
Well,
this
yeah.
in the future, so
We're
I have
going
no
through and
care for it.
Music, JD? Here, TJ?
Sometimes my
Right hand in the.
Go ahead.
like
Go ahead.
gold music playing.
Yeah, it's really awkward. And then you realize you're not listening to music.
I just have
Oh.
because the council's. Like one time I drove by council. Can't have it.
I'm freaking. Move that bus.
They do.
One.
Oh, yeah.
Alright, so we're gonna calculate some of these.
It's dumb.
So we're going to look at some of these now. So I'm going to find the cube roots of three different things. 0.008, negative 1,000, and 1 over 27.
Wait, whoa.
So we're going to find cube roots. Yep.
0.008.
So a cube root is, I really want to know what to the third power equals whatever I have here. That's really a cube. Actually, no, I'm not going to write it that way because that's going to be a mistake. That's you just transferring.
Oh.
0.3
Alright, so actually we'll just talk about,
in class.
no, we'll just work on calculating these.
What? I already did the in class.
We're gonna do them, I'm trying to decide how I want to do them. If I want to do this right now, or if I want to do it later. We're gonna do it.
I just typed it in.
So for right now, we talked about this piece right here. We will use this a little bit, but right now we're just gonna practice calculating a few things based on what we have. Alright, so my first one, I'm gonna find the cube root of 0.008, right? So a cube root means my index is 3.
Obviously, it's a one.
So that means my index is 3. So when I look at this, my index is going to be the same as that exponent I was just talking about. If my index is odd, I just plug this in and I don't even worry about whatever I get. I don't have to worry about it. So my index is odd. I'm just going to erase this right here.
Two answers.
0.008
You
And
get 0.2.
0.2 for my answer here. 0.2. Alright, let's do the cube root
Is that right?
of negative 1,000.
Oh, for that one?
And I'm just going to plug that in. When their exponent is odd, it doesn't matter what you plug in because you're going to get an answer. So negative 1, 0, 0, 0. And I get negative 10. Alright. You guys are actually going to do the 2 in-class problems together in just a minute. Alright, my next one, I'm going to find the fourth root of 1. So my index, the number on the
0.25.
outside is 4.
No, never mind.
No. So my index is 4. I'm going to do the fourth root of 1. Yeah, I'll go back to Desmos.
I got you. It's 1.
It is going to be 1. You can probably do that one in your head.
Well,
I just want to type it in so everybody can see. 1 right there. Yeah, fourth root of 1 is 1. That was kind of lame. Alright, how about the next one? The fourth root of negative 0.0001.
It's undefined.
So, on this one, my index is even, right? It's just like with square roots. Can you square or take a fourth root of negative?
No.
So for this one, I'm just going to say no solution. We're not going to worry about imaginary stuff right now.
Why not?
So don't worry about imaginary numbers right now.
But if it wasn't negative?
Then you can do it.
Would it?
Alright.
Almost here, I'll do that.
Yeah.
Oh, that's smooth.
Alright, your first 2 in-class problem, I want you to calculate these 2 in the boxes. And when you plug these in, like when you do the first one, just put it in like a fraction, 1 over 27. We're actually going to learn some shortcuts. You're just going to get a decimal to start with. So remember, to find your radical button, you have to go over here to Functions, and then you have to click on Miscellaneous, and then it's by the percent sign.
Okay,
Yeah.
I had a question.
Okay, what's your question?
You know, you like actually visually see it to see if this makes sense.
No, I don't know.
Okay. So I don't know if this makes sense.
Oh, is that how you do
But you should have put it.
The way I wrote that, does that make sense? Like, work it like that.
It'll it'll look like the other one. Just plug it in.
What?
Yeah, but also be careful. What's your index on this
That's a 4.
Wait.
Thank you.
Just not work down.
Do it.
It makes a little dash on top, right?
Yeah, because it's repeating. Are you sharing a graph?
No, I'm saving it so I don't have to do it.
What? So you have to just type it in?
Yeah.
Laziness at its finest.
Hey, I'm using my tool.
I know. No, I'm not saying that's bad. It's good.
He's all way to be lazy.
I approve. I
You're
approve,
really
Austin.
learning from me, aren't you?
All right, let's look at this first one. The third root of 1 over 27.
Yeah, plug
Oh,
in.
Let me pick somebody random. What? What did you get?
I got 85. That's it.
No.
I love me.
Damn.
All right, Carissa, what'd you get for this one?
45.
Yep. 0.3 repeating, right? All right, for the next one, the fourth root of 16 over 81. What did you get, James?
0.67.
0.67, or I think you get 0.6 repeating, round it.
There's a 7 at the end.
Yeah.
That's because Desmos automatically rounds the very last one. All right, not too bad, at least hopefully for this first one. All right, let's see what else we're doing. All right, so a couple more things.
Look at that. I'm gonna wait for the radical one.
So, when we look at this, if we have, so we kind of talked about this already.
Search.
If you have something to an exponent and you are putting a radical on there with the same index as your exponent, those cancel each other out. Hey, hush! I'm gonna give you guys a seating chart. Make sure you shut up.
Over there.
I thought we did have a seating chart.
Radical.
No,
That's why we're
I
back
stopped.
here.
I stopped doing it.
Just put it
What?
right
I
What?
guys
We
don't
do have
handle
a
it.
seating
I
chart.
was there.
I can't.
We're in our sciences right now.
All right, now shush.
Perfect when it was
We are not. I know we haven't done lessons in a while, but still. Okay. So, when we look at things with exponents and radicals, they are opposites of each other. They cancel each other out. So, when I look at these, I'm going to have one of two things. If the number inside that has an exponent, it is going to be whatever that thing is, whatever it is, if your exponent is odd. So, for example, if I have the fifth root of 2 to the fifth, because that exponent is odd, it's going to be just 2. If your exponent is even, though, can we take an even index on a negative number?
Yes.
No. Not without doing imaginaries. So, can I square root a negative 4 without imaginary? No. So, remember, the square root is
Yes.
exactly the same as every other thing with an even index. So, because I'm going to calculate this one right here,
They're numbers.
the fourth root of 5 to the fourth is going. What?
Numbers.
Alright, fourth root of 5 to the fourth, the exponent of 4 and the index of 4, they cancel out, and I'm going to get the absolute value, which in this one is just 5.
I'm sold.
Yeah, let's restart the lesson.
Okay, let me back up.
Let's just restart.
Alright, how about this one? Can I square root a negative 3?
Actually, no, that'd be bad.
So when I do this, my answer, because these cancel each other out, right? Whenever this is an even index and an even exponent, whenever I cancel them out, my answer is the absolute value on that. So it's going to be the absolute value of 3, which is really just 3.
Do we have to write
No,
absolute value?
I'm not writing absolute value.
Remember, it's automatically 2.
Oh, it is.
Remember,
Wait,
square
so
roots
what's
mean
that?
the index is automatically
So
2.
if there's nothing that's automatically.
Yes,
No
it's
thing?
like, yes.
What's the
So
number
it's
that's
just like,
in the
if you have an
thing?
x, there's automatically a 1 out front, right? Same thing with square roots. If there's nothing, it's automatically 2.
Cool, he's giving us this. Here,
Boo-hoo.
you good to go?
Yeah.
I don't even know.
Hypotenuse.
Alright, So we might not finish this whole thing, because I want you guys to practice, but we're going to do a little bit. Alright, we're going to use this on our next piece, and this is the main part of our lesson. We've actually kind of done this before. You guys remember difference of squares and the sum or difference of cubes?
No.
It's similar. Not as much, but it's similar. Alright, I'm going to take the square root of 16x to the 8th. What I want to do is rewrite things so they have an exponent of 2 in it.
Why?
How can I rewrite 16 to have an exponent of 2? Because we're going to simplify
Four.
this.
No,
Right?
yeah.
Okay? So whenever you have a number, just see if you can, like in this one, since it's a square root, see if you can square root the number and rewrite it. On my next one though, I have x to the 8th, right? I want to rewrite that so I still have x to the 8th, but I'm going to need to put something inside parentheses here.
Would it be like x to the 4th?
It would be x to the 4th. So remember, whenever you have an exponent outside parentheses, you multiply these two things together. X to the 4th in parentheses and then squared, you multiply your exponents together to get x to the 8th.
No.
So, yeah, you know what? I'm not even going to worry about these because that's just.
Good job.
I'm ready. Hey.
It's fine, Daisy, it's fine.
Can you like reveal the last one?
No, I don't have like a.
Calm down. Calm down.
I'm glad you put the line through the Z.
That was
Thanks.
fancy.
Why?
So it's like 2's if I
You
can.
trash.
Alright,
Yeah.
so all we did was rewrite these
It looks
things.
like my handwriting.
So I'm going to rewrite 16 as 4 squared. And I'm going to replace 16 with 4 squared instead. So the square root of 16 is
Kind
4
of
squared.
offended.
And I'm going to rewrite x to the 8th as
What the?
x to the
Whoa,
4th in
dude.
parentheses squared.
What's going on here?
I am rewriting this so I can simplify it.
X4.
That looks like a lot more writing.
It's not, it's really quick, I'm just not skipping steps. Okay, so square root and squareds cancel each other out, right? Because they are opposites. This square root has an index of 2, even though we're not writing it.
so stupid.
The index of 2 cancels out the exponent of 2.
What if that number is different?
Yep, on both of them. So when I square root these, the index, my square root, cancels out all of these exponents. And I'm left with 4x to the 4th.
Wouldn't it still be in the
Why can't we just?
square root though?
No, because it's
Can we
canceled
do
out.
this and skip all of these steps?
Yeah, you
Because look at
probably
it.
can. You can, that's fine. I'm just not skipping steps while I go over it.
Just cut it in half.
Wait, so when we're done, we can
Why
just
can't it
skip
be-
this step right here.
Yes.
You could have taught us this a way easier way.
I'm just not, you can skip steps, that's fine. I'm just not doing it because I want everybody to see all the steps.
Why?
I want you to see it. Alright, let's look at this next one. On part B, I am going to take the third root of a to the 6th, b to the 9th. Okay? I'm going to rewrite
A
a
looks
to
so
the
weird.
6th as something in parentheses to the third power.
A to
Because
the
my
second.
index of 3 is going to cancel out my exponent of 3. So it's going to be a squared, right?
Yeah.
Alright, how about b?
Help a B out.
B cubed.
b cubed, right? 3 times 3 is 9, b to the 9th, perfect.
Oh. Yeah.
So it would just be a squared, b squared, b cubed. So it would be
I'm not going to skip steps. You can if you want to.
Skip them all. Just give us the answer.
Alright, so I'm going to replace a to the 6th with
A to the.
a squared.
second, B to the third.
This is weird.
A little bit. It's not too bad though. Once you get used to it, it gets pretty quick.
Can I just write?
In parentheses.
Start writing just like random languages.
So a squared
What's
on
the name?
third,
What?
right?
What Brandon say about us not showing up Friday?
He hates you all.
Is that one of my cat box isn't done yet?
Yeah. Probably.
None of us showed up.
People that went.
Yeah.
And then some sketchy guy gave us jerky.
Yeah, this guy
Smell
that
like
came up,
alcohol.
like, gave us
Really?
jerky, we just threw it away. That's
I wouldn't
weird.
eat it.
He's
No.
like, oh, you're not who I thought
Did
you
you
were.
eat it?
No.
You're
jerky.
Tossing
He was saying, he
How
was
much
like
was it?
eating it out.
That's
He left.
weird.
It was 4
Alright.
pieces.
Alright, hey, Ash, we gotta finish this.
No.
Okay. So, my index of 3 cancels out all my exponents of 3. I'm left with a squared.
Don't say it again.
You get there.
Snoozing.
Is that what's up?
She's
That's why she
I got
was
one.
go.
Alright. What? Alright,
I forgot what we're doing.
let's try one more, and then we'll be done. Wake up, Melissa.
Okay, what are we doing? I forgot where we're at.
Yeah, we're on part C. Alright, we're gonna do one more, then you guys will try a couple, that'll be it. We skipped it.
Why did we skip it?
Because we just did. Actually, no, it was the last slide.
Oh, it was that one.
Alright, so I have x to the 8th. I'm going to rewrite that. So I'm going to do the 4th root of x to the 8th, y to the 12th. What do I need to put for my exponents inside? X squared, right? Okay. How about on this y one down here?
Y to the third.
Yep. And then, as I'm sure you guys don't need all the steps, what's my answer going to be after I simplify?
X squared Y3. Y3.
There it's...
CP3O.
Alright.
CP3O.
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 Okay, so
R2D2.
What?
OB1.
Wait, what?
Alright. So let's have you guys try one. Let's have you guys try part B right here.
Oh, that's gonna be
Yeah.
It could be an element.
Why don't you do part B? If
5.
you guys do good on that, maybe we'll skip part C and just do the exit ticket.
OB1.
ah,
What are we doing? I was listening.
Part B. Oh no, it was lame.
Right?
Alright, do part B.
Yeah.
Yes.
Hey, educate.
Oh, are we doing C?
Not if people do good on B.
It was right.
wait.
We got the same answer.
Probably right.
Oh.
I don't know if he's right.
I don't know.
That makes sense.
I don't know anymore. What is life?
What was that, player? Okay, I'm gonna see my clothes made here.
So this is the answer.
Devin, what'd you get?
Yeah.
Yeah, that's what I got.
Ow.
I wasn't earlier. I wasn't sure where those three.
So I'm gonna rewrite this, right?
I'll say-
So I'm gonna write it.
I didn't know where it's
I have
coming
parentheses
from.
now.
I thought it was still right.
Index.
A4, B5.
So how would I read it?
So
Greg.
Be able to get this here. Freeze.
What'd you leave? Why'd you leave it in here?
That's where it's coming
No, it's 4B.
Oh, my eyes are
from. It's a 3.
Oh, that's just 4. No,
Which one?
this one is not that. Cancel out. It's 2.
Start with
They cancel out, and it's just 2.
the same as you
Bring
index.
3 down.
Isn't it?
You bring
No.
3.
Because you do like this. See,
I'll tell you.
right here. See, we put it like this.
It'd be 8.
It's 4.
So that 4 multiplies 3 is 12.
Oh, this one.
Yeah.
Oh. Yeah. You just cancel out. And this is
Yeah.
But do you square root it afterwards, or does it
Hold
cancel?
on.
Bring that
Cancel
down.
out.
Yeah.
Which one are you talking about?
Because of this is wait. What?
I want to go home, girl.
Oh, then this
How do you do
is
this?
This is 3, 2.
Well, X,
X,
I don't know.
Y,
Y,
2.
2. Okay. That's the answer?
Yeah. Just 7.
Wait, are you going to today?
Alright. Not if you guys do good.
I'm not going out.
Or you just ranging?
Yeah, I'm just ranging. This guy.
I don't.
He's gonna hurt himself out there. I'm gonna laugh.
Just walking, stepping in a hole.
So,
Remember when we were crashing like 3 times?
whenever we have stuff inside of it, multiply the exponent.
Yeah, I was
Who
leaving.
did?
Like, when I was going out, I just saw when we crashed into the
Or you guys got the journey.
Yeah.
Here you go, Goki.
I would roll much for you, but
Is that why you guys can't drive anymore?
yeah, basically.
Right?
That day too.
So what is
Yeah,
it?
he was doing cookies at you, weren't you?
Yeah.
You idiot.
Yes.
You know that.
Huh.
Alright.
You never told me that.
Alright, we're going over part B. If you guys do good, we'll skip
No,
part
you're
C
with
and
me.
just do the exit ticket.
Hey, everyone did good.
Let's find out. Alyssa.
What? I don't know.
That's my favorite.
I was just kidding.
A4 would be
Alright.
fine.
A4. Wait, are we just supposed to say it?
Sure.
Barely drove on.
Okay.
They didn't
And
need any steps for this.
I barely drove on.
No.
sounds like it.
I thought he did.
Alright, we can hit the 4th, do the 5th. Not bad. Actually, as I was walking around, most people had it, so I'm not real worried. So, we are going to skip part C, and you guys are going to go on to your exit ticket.
They were singing.
So, go to your exit ticket here. I will turn on Scratch in just a minute,
Oh,
and
before
put
you
your
come
homework
back.
on there in just a minute.
You know how it's like up there?
Yeah.
So like, I was over here, get the ball,
Wait, just
go putt
before?
real quick.
Yeah.
He's getting like hustles. Like,
They're just
green.
Oh my God.
Oh, I know we're